We'll start today with a ThreatX architecture, talking about how ThreatX operates in your network. I'll walk through this diagram beginning on the left. We have your incoming traffic from the outside world. This is your legitimate users, suspicious traffic, and obviously malicious attempts coming in and going towards the right, your origin. The right is representing your point of origin, and this is where ThreatX is completely agnostic with the ability to be deployed to any data center, private or in the cloud. Now, ThreatX sits in the middle with our security container. And what's unique about the ThreatX security container is that we're doing a lot of different things in here compared to other players in the space. And I'll explain exactly how as we walk through all of its operations. First, ThreatX detects misuse and malicious attempts targeting your APIs and web applications in many different ways, beginning with application and API profiling. This is understanding how the application or API is standardly used and identifies differences or abusive behavior. A lot of players are doing this today, but combining this context with the following is how ThreatX is truly unique. IP interrogation is how ThreatX watches a bad attacker. The IP is being tracked to see how it behaves, and if needed, ThreatX will challenge that IP to see how it reacts. How ThreatX is so unique is when an attacker recourses and rotates their IP, ThreatX uses advanced fingerprinting to continue following that attacker even as they change path or even migrate into a botnet. Spinning up multiple instances of themselves, we can track all of these nodes under one attacker view by taking this approach. Moving on to the SQLi and cross-site scripting analyzer. Everyone uses this, but the biggest difference here is ThreatX detects attempts based on behavior. We're looking for things in the request that could be made into an executable on the back end. A good example is someone uses the sentence, "I am going to select all users from my union." Now that's a benign sentence, and we want to make sure we don't block it like a regex-based solution would, just because it has basic SQL operators like select or union in the sentence. ThreatX uses context and inspects requests to make a logical decision before blocking, significantly reducing our false positive rate near to zero. Behavior in custom binary signatures. This is a capability that ThreatX supports specifically for business logic use cases and to enforce existing block lists. An example of this could be blocking users from interacting with a specific honeypot. Now, flow validation is one of my favorite features of ThreatX. This is understanding what a proper flow of traffic looks like to your environment. Let's say a user navigates to a banking application and attempts to directly access account details versus walking through a login process. ThreatX can block that user because they broke the normal flow of how the application is used. The last one is layer 7 DDoS. This is looking for a bad actor trying to access large uncacheable objects, request it over and over again as fast as possible to eat up all of your computing resources, triggering a denial of service and taking down your website. Now, all of this concludes the detection capabilities of the ThreatX security container. But once we detect it, we have to do something with this knowledge, which brings us to our next two sections, the decision engine and advanced firewall. Once ThreatX detects attacker behavior, that is fed into the decision engine to be analyzed and correlated against other activity in your environment. Attacker behavior is associated to stage and classification. Stage is where the behavior would fall in the life cycle of an attack, like early recon or mapping, all the way up to an exploitation attempt. Classification is based on an attack tactic being used, such as SQL injection or botnet activity. Once behavior is analyzed into a classification in stage, every attacker is assigned a risk score based on their activity. ThreatX uses risk-based blocking to automatically stop high-risk traffic. Risk scores are constantly being reevaluated based on the most recent activity, meaning risk scores will continuously go up or go down based on the traffic that's being seen by ThreatX. Lastly, ThreatX has its own advanced firewall capabilities built into the sensor that include actions like monitoring, blocking, and permanent blocking. What's different about ThreatX blocking is it follows a 3 strikes and you're out process, again, to ensure we're not affecting legitimate users. Like the example we mentioned above, if that attacker's risk score exceeds a certain threshold, ThreatX will automatically block them for 30 minutes Then we'll release that user. If they come back with more suspicious attempts, we'll block them again for another 30 minutes. And at the third strike, they'll be permanently blocked, removing the need for manual response or management. The advanced firewall also supports other unique response actions, such as tar pitting, so slowing down that attacker, making it more expensive to see if they'll go away. Rate limiting, slowing traffic down to a specific, more acceptable rate. And active interrogation, enabling ThreatX to identify advanced bots by pushing a cookie, challenging them, and see if the bot will accept or deny that cookie. All of these analytics and actions is taking place on the ThreatX container before being sent up to the ThreatX platform.